Hello. This video is going to be about squaring up your material or stock so that you can have other surfaces be perpendicular or parallel depending on the needs of the print. Now this is a piece of cold rolled steel, which cold rolled is the process that's used to make the steel, and it goes through rollers and it is just pressed to the shape and the size. The tolerance is a few thousandths. There's not much that would enable it to be square or perpendicular, meaning this being a 90-degree surface, which is what we need, and quite often many of the prints that we're going to use in order to make parts, because other surfaces stack up on top of it, and if it's not perpendicular when it's supposed to be, or parallel or 90 degrees, you can oftentimes end up making a scrap part down the road, even though dimensions are in tolerance. So one of the first things that we're going to need to do is to make sure that there are no burrs and raw and rough edges on here, because if we don't have something good to start with, we will not be able to end up with anything good. So the first thing that we're going to need to do is we're going to need to make sure that all of our raw saw cut edges have been deburred, and then we're going to take a file and we're going to go flat on the surfaces that we want to machine. Okay, so we lay flat and we file flat, and what we're really trying to do is take off the high spots so that it will sit flatter and not rock. You can tell because parts of it are shiny. Once I run the file on it, just rotate it. You want to get all four sides really good. Sometimes flipping it on the end makes it easier to do. So you get the fourth side. And this gets me started in this process. Now, we need to be able to check this for square. So how am I going to check this for squareness? 90 degrees. The two sides are perpendicular. One of the ways is by a square. Now this square right here is called a combination square. It's called a combination square because it can be taken apart, adjusted, moved, do combinations of things. We can measure 45 degrees here, we can measure 90 degrees here. The problem with this square is it's not super accurate. I mean, for rough work it's pretty good, but it's not very critically accurate. So what we really want to use in checking this is what's called a precision square, or oftentimes referred to as a machinist square. It only does 90 degrees. It is permanently fixed, okay, and it can be checked with some precision equipment to make sure that it is 90 degrees, because if I were to drop this, it would no longer be square. One of the ways that this can be checked is by something that is ground, precision ground, and in this case we have a precision ground V-block, where these outside angles are 90 degrees, this inside angle is 90 degrees, is ground to a very close tolerance. So we can put our square on here and look. What we're looking for to check is I would be looking to see if there would be any light shining right up here in between these two pieces. If I saw any light through when I held it up to the light, that would indicate that it's not square. I've checked this square, and this is really good, both on the inside edge of it, and if I want to check the outside, I'm going to check it this way. Okay? I could check the outside of the square to see that it's 90 degrees also. So I have a good square, and so now basically what I need to do with this part is I need to get one surface, as much of it as possible, on the back or the solid jaw of my vise. It's the non-movable one, it's the solid one. I want it to sit as far down as possible, and I would like no other surfaces affecting it as much as possible. It's critically important that we have absolutely clean machining surfaces. So we need to clean this out very well. We use a parallel. The first two sides are a little bit different than the last two sides in this process. And on the first two sides, what we're going to be doing is we want it to sit deep in the vise. So I clean my parallels. I set my parallels in. I wipe my part off the same way because I just filed it. I set my part in the vise. Now, in order to keep this front movable jaw from affecting this and potentially, shall we say, turning the part, okay, what I do is I need to use this rod. And what I have is this rod. It's a small rod, and it, from a side view, is going to look just like this if I were looking from the side of the vise. And what this does is this puts on the square stock is the solid jaw up against the square, and the round piece of round stock is where the other jaw would come in. And what happens is it only touches a small part of the round. Okay, like this is what's going to actually happen. And so therefore, everything is based off of this back surface here. And this, if I were to not put the round, could cause, because since these sides are not parallel, it could cause it to cock, to move, and then we wouldn't be getting a square surface. All right, so that's the purpose for all of this work here, is to try and take out anything that could bring error into us making this perfectly square.